Welcome everyone. My name is Elita. Today I'll be presenting Stream 101. Thank you so much for attending our stream, our session. If you have any questions, you can ask in the chat. And without wasting any more precious time, I will let Ben introduce himself. And well, stage is yours, Ben.
Thanks, Elitza. So hello, everyone. My name is Ben. Really appreciate you attending my session today. I've been working at IBM for nearly 4 years now, and I've been working in the Z part of the business for nearly 2 years. And within IBM, I work as a DevOps technical specialist, focusing on Z, so specializing in some of the DevOps processes and mainframe modernization software that IBM has. And the session today is lightning strikes, mainframe resiliency, and modern development practices. I'm going to try and cover a little bit of all three, hopefully in an engaging and fun way, because I think the mainframe actually is engaging and fun, and that's something we need to make more people aware of. So I'll start now. I wanted to start off and make the session as interactive as possible. So my first question to everyone in the room is going to be, how many of you have actually used a mainframe before? And I don't know if we have like a hands up feature in the virtual conference or something like that. But if you want to raise your hand, feel free, or just think about it, feel free as well. More than likely, it's going to be a lot of people in this room. But when I've done this talk or a similar talk in the past, I had less technical people, so there were less people. But anyway, another rhetorical question. How many of you have checked your bank balance today?
I
Yeah,
have.
I think I have as well, actually. Or how many of you have recently purchased a flight ticket? I was in France last week, so that's me. Or how many of you have recently bought something off the internet? Yep, there we go. Well, if the answer was yes to any of the following questions, then you will have used the mainframe. And the mainframe has been around for a very long time, most likely for longer than a lot of the people in this room have been alive. But since the inception of the mainframe, it's enabled humanity to make staggering achievements. And you can see on the left there the System 360, which was IBM's first mainframe. And that released all the way back in 1964. And without the System 360, putting man on the moon would certainly have been a lot more difficult, if not impossible. But we need to make no mistake that the mainframe is outdated technology, because it's absolutely not. The latest mainframe, the Z16, or it was the latest mainframe at the time of writing the presentation. We've now released the Z17 in April 2025, so that's the latest one now. Regardless, the Z16 released in April of 2022. But why do we call it the Z16, or why do we call it the Z17? Well, the Z in all of IBM's mainframes stands for zero downtime. And it means that it is very, very unlikely that any IBM Z system will experience any outage. And you might be wondering, well, just how unlikely is it for a Z system to experience any outage? Well, a Z16 mainframe is 99.9999999% reliable. That's 99 followed by 7 nines. It means that in a 1 year period, a Z16 will experience only 3 seconds of downtime. Or in other words, the likelihood that a Z16 will experience an outage is 0.0000001%. Now, that's a very big number, and I don't think we can quite grasp just how unlikely it is for a Z16 to experience an outage. So I'm going to try and put that into perspective for people. The United Kingdom has a population of 68.35 million people. And in the UK, each year, approximately 30 people get struck by lightning. Therefore, if we divide 30, which is the number of people in the UK who get struck by lightning each year, by the total population of the United Kingdom, which is 68.35 million, we can calculate the likelihood that any one of us within this room will get struck by lightning in a 1 year period. And this is why I'm going to try and make it a little bit more interactive as well. So I would invite anyone in the room to get their phones out or get calculators out and then go onto their calculator app and type in 30. I'll give people a bit of time if they want to do that. But yes, once you've opened your calculator app or got your calculator app out, type 30 and then divide that by 68.35 million. And the answer you should get is about 0.000000044. So that is the likelihood that any one of us within this room will get struck by lightning in a 1 year period. So let's just compare these two numbers here. In a 1 year period, the likelihood that somebody living in the UK gets struck by lightning is 0.000000044%. Whereas the likelihood that a Z16 experiences any outage in the same period is 0.0000001%, which means the probability of a person getting struck by lightning in the UK is literally over 4 times more likely than a Z16 experiencing any outage. And that to me is pretty incredible. But you might now be wondering one of two questions, if not both. Why do we need to make the mainframe so reliable? And how do we make the mainframe so reliable? Let's start by answering the latter. The concept of redundancy on the mainframe is almost as integral as virtualization. But what do I mean when I say redundancy? To put it simply, redundancy on the mainframe means having multiple backup components so that in the unlikely event that one component does fail, the entire system will still remain operational. Whilst the configuration may vary from mainframe to mainframe and the systems may have changed a little bit over the years, a typical Z14 mainframe, for example, will include 4 different power supplies to supply electricity throughout the system. Then within the data center where the Z14 is in operation, each power supply might be hooked up to a different power outlet. Therefore, in the event that one or maybe even multiple of those power supplies fails, the system overall will not be affected. On top of the Z14's multiple power supplies, you can see in the top left corner, there are also internal batteries, and the Z14 will have multiple of those. In the event our mainframe does lose power, or perhaps the data center where it is being housed due to maybe a natural disaster or some other catastrophe, the batteries will provide enough power to the Z14 system to make sure enough electricity is flowing through the system to enable a proper shutdown. And that would mean that no transactions in flight at the time of the disaster are lost and data concurrency would be maintained. And in addition to the multiple batteries and power supplies, we also have multiple support elements or SEs, which provide the interface through which we can interact with our Z14 system. Because our mainframe wouldn't be very useful if we had no way to access or interact with it. So it's quite a good idea to have multiple ways to do that. And you can see there are a lot of other components within a Z14 system that I've got on the slide here. And more than likely, those components will all have backup components as well to ensure that redundancy is maintained. And this concept of redundancy doesn't just apply to the Z14 system I'm showing you here, but throughout all of the lineage of the mainframe family up until the most recent Z16 and Z17 systems. I'll quickly go through some of the other examples of components within a Z14 system. So we can see, for example, the CPC drawers and PCIe drawers on the right-hand side there. And to summarize here, redundancy on the mainframe means that we have multiple components or backups, such as multiple power supplies or support elements, to make sure that our mainframe almost never experiences any downtime. So we've answered one of our questions. How is the mainframe so reliable? Now let's see if we can answer our first question. Why is the mainframe so reliable? And excuse me, to put it simply, but without overstating it, it's because the modern global economy is dependent upon it. 45 out of the top 50 banks globally, that's the likes of HSBC or Lloyds Bank or Bank of America, all use IBM mainframes to run applications which are critical to the survival of their business. And there are many other industries other than the financial industry who make extensive use of the mainframe. For example, the retail, airline, and healthcare industries, all of those are prevalent users of the mainframe. You can imagine how you might get more of an appreciation of the mainframe and what it does when you are not able to get into your surgery or pay your bills on time because it has stopped working. Luckily, as we have previously discussed, the likelihood of this happening is very, very low. Now, due to the sensitive nature of these applications and the fact that the mainframe has been around for a very long time, very few changes have been made to these applications for quite a long time. On top of this, these applications sometimes are poorly documented, which can make it difficult for developers to understand where they need to make changes. And when changes are made in an effort to improve and modernize, more often than not, the process for making said changes is done following development practices which could be considered out of date. Traditionally, software applications, not just on the mainframe, but on computers in general, such as the IBM PC or the Apple Macintosh, were developed following a practice we now know as waterfall development. And the waterfall development approach is linear. Well, what does that mean? Well, in such an approach, the first stage of the development must take place, well, first. One stage of the development process cannot begin if the stage prior to it, if there is such a stage, has not yet been finished. Hence, the approach is nicknamed appropriately the waterfall approach because it flows like water. You cannot, start at the bottom and go to the top, or start halfway through and then go back to the top. You have to start all the way at the beginning and then go all the way down. Now, the stages within the waterfall process can vary a little bit, but generally the following stages are included. So starting at the top, we have the requirement stage. And in the requirement stage, the development team may have a consultation with the end user in order to determine what it is the end product needs to do. Then we move on to the analysis stage. And in the analysis stage, we may assess the feasibility of the project we are about to undertake. Moving on to the design phase. And here, the technical aspects of the project will be specified. This could include which programming language we are going to use, or the type of hardware, or the system architecture which we are going to follow. I just need to turn the lights back on, sorry. There we go. And then we have the implementation phase, and that is where the developers will begin to write the program source code and work on the final software solution. Moving next on to the testing phase, where any bugs within our software will be identified and removed. Next, deployment, where the software is made available to the end user. And finally, maintenance, where any software patches or updates, perhaps to fix any bugs or issues that slip through the testing phase, will be applied. Overall, the waterfall approach to software development can take quite a long time. It could take weeks or even months from start to finish in order to incorporate some very simple changes. But I will acknowledge that there are definitely other factors which affect the time that it takes to develop applications or new features on the mainframe, other than what could be considered out-of-date development practices. And in some cases, having a lengthy process to properly assess the impact of a change, as well as make sure that the change we are doing is going to work for certain the first time is required. As I already mentioned, it would be a very bad day for a lot of people for a lot of reasons if the mainframe stopped working because we introduced a bug to the system because we didn't properly check whether the change we were making was actually going to cause that bug. However, in our increasingly interconnected world, where seemingly everything is available on demand or available with next day delivery, there is a push to speed up development on the mainframe and the incorporation of new features. And at the moment, the impression exists that on the mainframe, development is not only slow, but it's also difficult. But it doesn't have to be that way. And that's where people like me, as IBM's DevOps client technical specialist, come in. Through adopting practices such as DevOps and new tools, which have been developed using the latest advancements in artificial intelligence, we can make development on the mainframe quicker and easier. But what is DevOps? Well, traditionally within the software development lifecycle, there will be two teams. The development team, led by Dave on the left, will be responsible for planning, designing, and building software features. Whereas the operations team, led by Jane on the right, will be responsible for testing and implementing the software. The operations team provide feedback to the development team, and then the development team will be responsible for debugging. One of the problems with this approach, though, is that the dev team could be waiting a long time to get feedback from the operations team. Or in some cases, the development team may move on to the next project before that feedback ever arrives. So now you have the issue of there is a backlog of work that needs to be done. So it can take quite a long time for the development team to get around to actually addressing the issues raised by the operations team. But what if we could combine the two teams together? Then we could eliminate any friction between the two, and ultimately our cycle of delivering software and ensuring that it works properly would become quicker and easier. The whole concept behind DevOps is that we are continuously developing and testing new software, which is why we represent DevOps using the infinity loop. Within the DevOps lifecycle, there are a number of different stages, similar to how there are different stages within the waterfall development. But unlike the waterfall development approach, we don't necessarily have to follow them in a linear fashion. We can regress to previous stages if need be. If we receive feedback from the customer saying they want a certain feature or they found out that they didn't really like a certain feature, we can go back and make changes. It's not as rigid as the waterfall approach. But let's explore what these different stages within the DevOps lifecycle are. Starting out with plan, where we plan which features we want to add. Then we move on to code, where we write the code for those features. And we may have multiple versions of that code stored using Git. Then we have build, where we make our code executable. Moving on to test, where we identify any bugs or unexpected behavior within the software so far. Moving on to deploy, where we make our software available to users. Next, we have operate, where we maintain our software and make sure that it's kept available to users. And finally, monitor, where we monitor our software and report any bugs. Now, there is more to the DevOps methodology than this, but this is just a brief overview of what it entails. So we encourage our customers to adopt a DevOps methodology. But what other tools can we use to help speed up the development process on the mainframe? If you remember, I mentioned that during the code phase of the DevOps lifecycle, that some developers may opt to use Git in order to store multiple versions of their code. But what is Git? Well, Git is what is known as a version control system, or VCS. And if you were to look up on the internet or use ChatGPT to find out what a version control system is, you would get a definition similar to the following. A version control system is a piece of software which is used to track and manage the changes made to a project's code base during the development process. So whilst Git, the open source control system first released in 2005, which should not be confused with GitHub, that is a pay-to-use online service which is owned and operated by Microsoft. But anyway, whilst Git is perhaps the most popular VCS out there today, some other version control systems do exist, including Endeavor, which is quite popular within the mainframe industry. Some of the benefits of using version control systems include enhanced collaboration. Now we can have multiple developers working on the same project at the same time with our VCS, ensuring that there are no conflicts when it comes to finalizing our changes. We can maintain a history of who did what and when, which makes it much easier to identify how or why a problem was caused in the first place. Then, using that information, we can make sure that the same problem will not happen again in the future. And in the event that one of our developers does introduce a change which causes a problem or bug, we can easily roll back the change and revert to an earlier version of the code, which is being handled and maintained by our VCS. So, to summarize, it is recommended that developers on the mainframe adopt some kind of version control system in order to manage any changes made to their code, as it can help prevent any problems from arising in the first place or mitigate those problems if they do arise. But what other tools can we use to help speed up development on the mainframe? Well, how about using a modern IDE? An IDE, or integrated development environment, is a software application which consolidates multiple development tools into one solution. This makes it much easier for developers to write and update code. And perhaps the most prevalent IDE in the industry today is Visual Studio Code, which, according to the 2023 Stack Overflow Developer Survey, is preferred by over 80% of developers. Another prevalent IDE within the mainframe industry is also IDZ. Now, I know there will be some diehard mainframers out there who, no matter what, will always prefer to use the old school ISPF and green screen method to interact with the mainframe. And that's okay. For some tasks, those which might require greater control, these methods of interacting with the mainframe might be the best. But there are some enormous benefits which modern IDEs, such as Visual Studio Code and IDZ, can offer to mainframe developers. For example, automated code completion. IDEs can IDEs can suggest new snippets of code automatically based on the context of existing code, which can save developers time and reduce errors. Enhanced error detection. Modern IDEs can spot where a developer might have made a mistake, such as the exclusion of a semicolon or full stop, and then highlight this back to the developer. Where using traditional development tools such as ISPF, the process of identifying and then removing syntax errors could take hours. Well, using a modern IDE, it could take just minutes. And here is something else to consider. Every time you compile a program on the mainframe and it doesn't work, perhaps due to a very basic or silly syntax error, you are wasting your company's MSUs. Now, for those who are unaware, million service units or MSUs are one of the measures of mainframe resource usage. And it's one of the ways that IBM uses as a billing method to charge customers for their mainframe usage. And we could go down a very deep rabbit hole talking about the different measures of mainframe resource usage and capacity. But to make a long story short, every time you compile a program on the mainframe, it's going to cost you money. Anyway, back to talking about the benefits of IDEs. Another benefit being syntax formatting. Through the automatic indentation of code to where it needs to be, the colorization of variables or conditional statements or important blocks within the code, using more than just 4 colors, looking at you, ISPF, IDEs can make it much easier to read and understand source code. So, to summarize here, the benefits of using modern IDEs for mainframe development include automated code completion, enhanced error detection, cost and time savings, as well as automatic syntax formatting. But there is another feature which, as of yet, I have not yet mentioned, which is that which modern IDEs incorporate to make mainframe developers' lives so much easier. And that is the incorporation of the latest AI-powered tools, including Watson X Code Assistant for Z. Now, there may be some of you in the room who hear the phrase AI-powered and cringe a little bit, simply because today it seems that everyone is trying to incorporate AI into almost everything. Or maybe instead you've just seen too many outlandish responses from supposedly clever AI-powered chatbots. But within the mainframe industry, I genuinely think that going forward, there is a space for AI and the capabilities it has to offer. If I were to ask the question, how many lines of COBOL are there running on production systems in daily use, how many would you say? And similar to what we did earlier, you can put answers in the chat or just have a little think about it for a moment. Would anybody in the chat have said 8 billion lines of COBOL code? How about 80 billion lines of COBOL code? Or maybe even 800 billion lines of COBOL code? Well, if you guessed 800 billion, then you were right. And as we did earlier, let's try and put that into perspective. Sometime around 2022, it's impossible to know the exact date or time, but sometime in 2022, the population of the Earth reached 8 billion people. So we have 800 billion lines of COBOL running on production systems in daily use. And we have a global population of round about 8 billion people. If you do the math, you will find that for every single person on the planet, there is an equivalent of 100 lines of COBOL code. And those 100 lines of code look something like this. As a side note, for anyone who is interested, that is the COBOL source code for a game which I wrote, and I'd be happy to share it afterwards if anyone is interested. Quite cool, I thought. Anyway, as I alluded to earlier, a lot of these lines of COBOL make up applications which are very, very important, if not critical, to the survival of some very important businesses. And as a result, very little change has been made to these applications in a long time. Now, I cannot say with clarity just how many of the billions of lines of COBOL code are poorly or completely undocumented and not very well understood, but I would be willing to bet that it makes up a large proportion of the 800 billion. So, what do we do? Even if we do adopt modern development practices such as DevOps to push changes out quicker, even if we do adopt a version control system to manage all of the changes that we make to our code, even if we do adopt a modern IDE to make the process of writing or changing code easier for developers, if we don't understand the code we are working on in the first place, then all of this will do little to speed up the development process. But that's where Watson Xcode Assistant for Z can come to the rescue. Through its understand, refactor, optimize, transform, and validate capabilities, Watson Xcode Assistant for Z can not only help speed up the development process, but also help modernize code. Now, for the remainder of the presentation, I'm only going to focus on the understand, refactor, and optimize phases that a developer using the Watson Xcode Assistant for Z tool would go through. So let's start with the understand phase. As I said earlier, our code is not of much use to us if we don't understand how it works. Take the following scenario. I've been asked to make a change to one of the COBOL programs within my application, but the senior developer who best understands how everything works is on holiday, or if I'm really unlucky, he's just retired. I need to know that if I make a change in one COBOL program, it is not going to adversely affect another one within my application. Now I need to backtrack and trace how the application that I will make the change in is linked together and go down through all the different COBOL programs. And with 800 billion lines of COBOL programs out there, that could take a very long time. Would it not just be easier if there was a way that I could graphically map out how my different programs link together? Well, luckily, that is just what we can do during the understand phase of What's the Next Code Assistant for Z. I can graphically map out how each of my COBOL programs is linked together and interacts with one another. And in addition, suppose there is a bit of code within one of these programs which I want to gain a deeper understanding about. I can use watsonx Code Assistant for Z to generate a report to summarize what the code is doing for me. So through watsonx Code Assistant for Z's understand phase, I've now been able to gain a deeper understanding into how my application works. Great. What else can I do? Well, how about code refactoring? If my application has been developed over the course of 20 or 30 years, more than likely it has become quite bloated. Maybe not all of the code in that program may be required to be there in order to get the job done. So why not take out the bits of code that we do need and create a new service entirely without all the bloat? And that is what we can do using watsonx Code Assistant for Z's refactoring assistant. And last but not least, we have watsonx Code Assistant for Z's optimize feature, which I can use to ensure that my code is running as efficiently as possible. And before I move on, I would like to emphasize the fact that watsonx Code Assistant for Z is not just for junior developers, it's for all developers on the mainframe, whether they have 4 years of experience or 40 years of experience. Everyone can take away benefit from using this tool. So I'm wary of time, but I think now would be a good time to try and actually show you the tool in action. It should only take a minute, and then I'll be ready to answer some questions if there are any. Okay, so in the following scenario, we're going to take on the persona of Deb, who is a COBOL application developer working at a large insurance company. And Deb has been tasked with modernizing one of the company's key applications. Deb is going to use watsonx Code Assistant for Z to generate an explanation of some code so she can gain a better understanding of how it works. Then she's going to insert the explanation generated by watsonx Code Assistant for Z as a comment into the source code. So to begin with, Deb can go through the program and find an area that she wants to gain a deeper understanding about. In this case, it's the insert customer paragraph. Deb can highlight this paragraph and then right click, and watsonx Code Assistant for Z gives her 3 different options. She can generate a simple explanation, a detailed explanation, or a guided explanation of the code. Deb opts to generate a detailed explanation, and on the right hand side, a window opens where watsonx Code Assistant for Z will generate that explanation of the insert customer paragraph. Before inserting the explanation into the code as a comment, Deb is going to review it just to make sure it all looks okay. And then by clicking on the icon, Deb can quickly and easily insert the comment. So now she has a detailed explanation of how that paragraph is working. So in the future, when other developers come back and try and figure out what's going on, they'll have more of a opportunity and a greater understanding. So that's everything from me for now. I've got some time for questions. Sorry, I've stopped sharing my screen. So yeah, now I'd like to open up the session and give anyone any opportunity to ask any questions that they have.
Please, people, don't be shy. Ah, unmuting. I will
Right.
unmute you. Okay.
Hi guys. Yeah, if you wanna choose to unmute the whole, not to unmute the whole lot of people, but just allow people to unmute themselves at some point, that usually helps a little bit. But yeah, sorry, I just had a question to Ben on. I think it just I still don't know with Watson Assistant for that what level of hardware you need. Is it already available on Z16s, or are we looking at Z17s only?
So I don't want to say anything incorrect, but I can get back to you with some more information on it because I don't want to say anything incorrect there. Sorry, that's a bit of a cop-out question. But I know we have the demonstration available that I've just run through. Anyone can go through that on the internet.
Right. Okay. No, it's fine. I was just thinking that, yeah, it's I see a lot of, I've spoken to Eddie as well, and I see so much benefit from this, but I just don't know if I'm even able to suggest it for my team to have a look at if we're not running the right, we don't have the right level of hardware. Hopefully, hopefully I can just find it out throughout the GSE. What do we need for that?
Sorry, it's Jeff Eggleston here. I mean, prior to the Z17, we always we ran it. It'll run on the Z16, but we have to go and look at which one, what other models it'll run, and I suspect it's also down to operating systems as well. So, but Z16 and Z17. As for the other ones, I'm going to let Ben do his homework, and he can let me know as well. Bless.
Some homework for you, Ben. But thank you. Thank you for that, guys.
No worries.
Appreciate that.
Happy to do it. If there's no other questions, I suppose thank you everybody for attending today. Been a great audience. I'd really appreciate if anyone can do any feedback. It's the first session I've ever done at GS UK. It's not GSE anymore. It's something that I'm looking to build upon. Hopefully do a few more sessions at the virtual conference and the in-person conference as well. So here's all the details of that. And yeah, just really appreciate everyone making the time for me today.
Well, thank you everyone for visiting our session. Please leave your feedback. And well, if that's everything, just feel free to jump into another session. And thank you again. Thank you, Ben.
No worries.
Bye.